Hello guys, welcome back to my channel Maison African Motives. Still working on O-level mathematics. So in this platform we have got the question paper that we are going to focus on, November 2008 paper 1. So I shall just quickly rush through this paper, and you shall just pardon me today, where I'm situated. There is a lot of traffic and so on, so I just hope it is not going to disturb us as we are moving on this revision. All right, so I shall just quickly rush through the questions that you're given. As you know, guys, remember I told you to read your instructions and everything. This is paper 1, no calculators in this paper. All right, so let us quickly see the first part. We are given to simplify 6,3 times 1,1, giving your answer as a decimal fraction. So in this case, this is what you get. So you're just going to multiply here, 6,3 multiply by 1,1 like this. Okay, so remember, when you are multiplying, you ignore the commas. You just treat this number like 63 and this one like 11. So which means we are going to need a placeholder of 0 here. Then we multiply 1 times 3, which is 3, 1 times 6, which is 6. We are done with 1. Then we move on to this one here, 1 times 3, which is 3, 1 times 6, which is 6. All right, so we can add our terms so that we can have our resultant, which is 3 here, 9, 6. So we're going to have 6, 9, 3. And now how many decimal places? We've got 1, 2 digits after the comma. So we're going to have 6,93, since we're supposed to have 1, 2 digits after the comma. So we're going to have 6,93. Okay, so that was it. And the item 2, let's just save it even here. 2 over 3 minus 3 over 4. So what are we going to have? Definitely we need the LCM of 3 and 4, which is 12. So you can divide 12 divided by 3, which is 4, and multiply to 2. So 4 times 2, that is 8, minus 12 divided by 4, that is 3. 3 times 3, that is 9. Okay, so if we subtract 8 minus 9, is minus 1, same as 9 minus 8, which is what, then you take the sign of the bigger number, so it's minus 1 over 12. Right, so that is what we had. And the B part, you're asked to find 5% of 130 meters. So as you know, guys, to remove the percentage, it simply means over 100 multiplied by 130 meters. Okay, so that was it in this case. So you can actually remove the zeros here. 5 into 5, that's 1. 5 into 10, that is 2. 2 into 2, that is 1. 2 into 13, that is 6. We've got 6 remainder 1 here, which is going to be 6 into 10, 2 into 10, which is 5. So we're going to end up with 6,5 meters in this case. All right, so that's what we have as a 5% of what, of 130 meters. We just have to remove the percentage, then multiply to that resultant, just like that. Okay, then 2A, we're asked to evaluate giving your answer in base of 6. So the first part, you're just adding the numbers, which is 5, 4 in base of 6 plus 3, 0, 5 in base of 6. So you just make sure that these numbers are in line when you are adding them, starting with the last digit, which is these ones, they must be in line. All right, so let us add, we are going to add in this case 4 and 5, which is going to give us 9. But 9 is more than the base, which is 6. So remember, you divide by the base when it is greater than. So if we divide, that's 1, remainder 3. So the remainder on our answer, we are in base of 6. Okay. So we are going to write the remainder, which is 3. Then what about this one here? We carry this one into the next term, which is going to be 1 plus 5, which is 6, plus 0, which is 6. We do the same, 6 divided by 6, which is 1 remainder. As long your number is equal to the base or more than the base, that is where you have to what? That is where you have to divide by the base. As long it is more than the base or equal to the base. All right. So the remainder part on our answer, we've got a remainder of 0 here, then the 1 we add to this term. So we're going to add 1 plus 3, which is 4. So it's going to be 403 base of 6. Okay. Then the B part, convert 10011 base 2 to a number in base of what? To a number in base 3. So we're asked to convert this number to base 3. So as you know, we have so many ways that you can use, but you guys are used to converting this to base 10 first. So that's what you're going to have. This one will be 2 to the power of 0 here, to the power of 1, to the power of 2, to the power of 3, to the power of 4. So we are raising these numbers in base of 2, which is 1 times 2 to the power of 4, plus remove this one, that's a 0. So instead of using this 0, we just ignore it, or you can just write 0 here, plus the next one, and obviously if you multiply it, is going to be a 0. Then we move on to this one here, which is 1 times 2 to the power of 1, plus this one, which the last one, which is 1 times 2 to the power of 0. Okay. So that's it, guys. We can simplify here, which is 2 to the power of 4, which is going to give us 16. So if you multiply 16 times 1 is going to give us 16, plus this is a 0 here, this is a 0 here, so there's nothing. We do the same, 2 to the power of 1, that's 2. 2 times 1, which is 2, plus 2 to the power of 0, which is 1. 1 times 1, which is 1. Okay, so if you add this, it's going to be 18, 19. So that's what you're going to have. 19 in place of 10. Yes, you can write the base, or you can even choose to leave it like that. Okay. Now that we have got our number which is in base of 10, we know that we can actually convert this to base of 3 by dividing by the base, noting the remainders throughout. All right, so that's it. Let us divide by the base, that is 3 into 19. Remember, it's going to be into 18, which is 6 times, remainder 1. 3 into 6, which is 2, remainder 0. 3 into 2, that's 0, remainder 2. So that's our answer, taken from the bottom going upwards, which is 2, 0, 1, base of what? Base of 3. All right, so that was the conversion that you can simply do. All right, then number 3, you are given 94 times 152. If you multiply these two numbers, you obtain 14,288. Now find the value of n if 95 times 152 is plus n. So I want us to see this, but for you to get this 14,228, this one, you got this one when here it was a 94, when it was a 94. Now this is 95, which means you have you multiplied 152 94 times. That is for us to get this value. So the n here is definitely an extra 152, because here we are given a 95, so which means 152 was multiplying itself 95 times. Now we used what? 94 to get us this one. So this n is just an extra 152 that we are having. Okay, so our n there is going to be 152. Okay, then now we move on to the B, the exact value of these two numbers that you're asked to multiply. Okay, so what are you going to do? You are going to use this relationship that you already have here. This is the relationship that you already have. But take note here, this is 0,094. This is 1,520. It's no longer 152, it's now 1,520. Okay. So it means if we were to multiply 94 and 152, these two, we are going to obtain 14,288 like this. But here, because it's now 1,550, we are just going to multiply this answer by 10. And by multiplying this answer by 10 is just having an extra 0 like that. Okay, so that is when you multiply 94 to 1,520. But remember now there are decimal places that we can see here on 0.94. How many decimal places that we have? We have got 3 decimal places. The numbers after the comma, 1, 2, 3. So which means we shall count 3 digits after the comma on our answer, 1, 2, 3. So our comma is going to be somewhere there. All right, so that's what you're going to have, which means you're going to have 142,88. The 0 there does not count now, so it's just going to be 142,88. All right, which is the same thing on item 3. You are dividing this one, so you target this result, and this is what you know, this one. This is what we know, and this is what we know. So we target that. So you're going to have 0,14288 over 0,0094. Okay, so let's try to get rid of the decimals which are in the denominator. How many decimal places we have? 4 decimal places. So you multiply by 10,000 just to remove the comma by 10,000, so that at least we can see the number. So it's going to be 1, 2, 3, 4, which is 1,428,8 over. If you move 4, it's going to be 1, 2, 3, 4, which is going to be 94 like this. Okay, so here we were supposed to obtain, if it was 14,288 like this, it was going to give us 152. But take note, it's now 1,420,8. So which means we're just going to have one decimal place back on this number that we are supposed to get. Remember, we're supposed to get 152. But because of the comma, one decimal place, we're just going to move one decimal place like that. So which means our answer is going to be 15,2. So you're not doing or those divisions that you're not using that. You are given a condition to work from. Given this, work from that part that you are given. So that is what we are having there. Okay. So let's cross-check the other part on 4a. Simplify 0,2 to the exponent of 3 times 0,2 to the exponent of 2. Give your answer as a decimal. Okay. So here, what are we going to do? We are going to apply our laws of exponents. We are multiplying the bases here, which are the same. So we are going to simply add the exponents. So it's going to be 0,2 to the exponent of 3 plus 2 like this, because we are multiplying the bases which are the same. Okay, so from this part, what are we going to do? We are going to ask ourselves now, if we can express this, okay, well, which means we can express this, which is 0,2 to the exponent of 5 like this. So this is what we are supposed to have actually like this, 0,2 to the exponent of 5. And we know that 2 to the exponent of 5 is 32. So in actual sense, guys, you're supposed to multiply 0,2 times 0,2 times 0,2 5 times. So what you simply do is just raise this to the exponent of 2. 2 to the exponent of 2 is what? Is 32. And now, since you are raising to the exponent of 5 and you already have one decimal place, so you're going to have one decimal place, another one decimal place, another one decimal place. So which means we are going to have 5 decimal places on our answer. So we're going to count 5 digits: 1, 2, 3, 4, 5. So it will be like this: 0,00,032 with 5 digits after the comma. So that is what we get from this part. As you can see, guys, it's direct there. Then the B part, solve the equation. What are you going to do? Expand brackets definitely by minus 2x. The part that is on the bracket, this one, which is -2. So it's -2 times x. That's -2x. -2 times 3, which is -6, is equal to 9. Then we can collect like terms. 5 minus 2, that is 3x, is equal to, transpose the -6 to the other side of the equation, is going to be a plus. 9 plus, is going to be a 6, sorry, positive. So if we are to add here 9 plus 6, which is a 15, yeah, that's it. It's a 15 there, divide by 3 both sides. So we can have the value of x, which is in this case 3 into 15, that is 5. All right, so that is the value of x that we got from this question. So guys, what you need is to revise as much equations so that you'll be able to understand the basic part of expanding brackets, whatever condition that you'll be given. Okay, write down 0019 as a 24-hour notation. Okay, so this one is 12.19. And which time is this one? This is in the morning. So this is AM in the morning. Okay. Tapiwa and Netai, they share some money in the ratio of 2:5. This is the ratio that they use to share their money. Given that Tapiwa, so 2:5 is the ratio of Tapiwa as to what? As to Netai. So Tapiwa is having 2 parts and has got a share of 620,000. Calculate Netai's share. So you're simply saying Tapiwa with a share of 2 got $620,000. What about Netai, who has got a share of 5? What is she going to obtain? We do not know. So as you can see, this is going to be more, which is 5/2. Here, the more value, the bigger value over the smaller value times what you're given, which is 620,000. Okay, it's just like that. So guys, you just have to do your proper division here. 2, that's 1, 2, that's 3. 2, that's 1, 2, that's 0, 2, 0, 0, 0 here. Okay, so if you multiply by 5, that's going to be 1, 2, 3, 4. 4 zeros here, that's 1, 2, 3, 4. Okay, then 5 times 1 here, which is 5. 5 times 3, which is 15. So we're going to have, okay, let us just rewrite this because we've got 3 digits here. So it's going to be 1, 5, 5, 0, 0, 0, 0, like this. All right, which is 1,550,000. So that is the share that NetSci is going to have at the end. All right, then number 6, we are given a diagram that we are given these two sides, they are equal from B to C and from A to C, these two sides are equal. All right, then the question is to calculate the angle of BAC. Take note of the parallel lines and this and that. Okay, so where is our BAC? This is BAC. This is the angle that we are supposed to calculate. Okay, so using triangle BAC, if we are to use this triangle BAC, we know that this is an isosceles triangle because we are given these two sides which are equal. So the angles which are opposite, they are equal, which means this angle at B and this angle at A, they are equal. So how do we find each of those angles? We just need to subtract 50 degrees from 180 degrees, this one, and whatever that we get, we divide by 2. So that is going to be 130 divided by 2, which is 65 degrees. So it means this angle is 65, this angle is 65. Since we said they are equal. Okay. So we have got our BAC, as we can see, that's our BAC, which is 65 degrees. Okay, because BAC is the same as what? Is same as ABC. These two, they're equal. AC is equal to angle ABC. That is for the angle. These two angles, they are the same. All right. Then DAC, on the other part, we've got DAC, that is DAC, this one, D to A to C. Okay, so let me just indicate this way. This is our DAC here, this angle. All right, so to find this angle, there were so many ways. If you are to cross-check, I talked about this concept, guys, of find of an exterior angle, where I told you that the exterior angle of a triangle is equal to the sum of the opposite interior angles. All right. If we are to cross-check this 50 here, it's an exterior angle of triangle ACD. It's an exterior angle. So it means this 50 degrees is equal to this angle at A plus this angle at D, which is 20 degrees. So that means if we add these two angles, they must give us the exterior angle. That is what it means. So to find the angle at A, which is our DAC, it is going to be simply 50 degrees minus 20 degrees, which is 30 degrees, just like that. Okay, so that's our DAC, which is 30 degrees here. All right, so I think that was actually the best way that we could have done. Yes, we could have calculated this angle here, that is with 50 here, knowing that angles on a straight line that up to 180, so we can calculate this angle at C, this one, which is going to be 100 minus 50, which gave us 130. So this one is going to be 130 degrees. All right. So knowing that this 130 degrees and this 20 degrees and this angle at A, they must give us 180 degrees. So therefore, our DAC is just going to be 180 degrees minus these two angles, which is 130 degrees plus 20 degrees, just like that. So you can obtain the same answer here, which is 150 degrees, and 180 minus 150, which is 30 degrees. So as you can see, we've got the same answer here. So it means this angle is 30 degrees at this point here, 30 degrees. All right. Then the last angle was to find ADE. Okay, that's ADE. That is ADE. This angle here from A to D to E. That is ADE. This angle that is going to be generated here. All right. So where are we going to have this angle here? Okay, take note, we have got parallel lines here, and we know that for interior, these alternate angles, they are equal, this angle and this angle. So we can cross-check that from the parallel lines. This angle at D is a alternate to whole of this angle here that I'm indicating at A, which is the whole of A consisting of these two angles here. We are going to create a Z here, as we can see. Let me just illustrate the Z that I'm preparing here. We are going to have a Z like this one. Okay, that's a Z that we are creating there. All right, so it means this whole angle is the same as this one. So we can take advantage from this angle at A. Why? We are given 65 and 30, so we can combine these two angles. So 65 plus 30, that is 95 degrees. So it means also this is 95 degrees, as we can see from our alternate angle. So that's our angle ADE, which is 95 degrees. So that's how you actually work out this angle, sorry. You can actually take from one to another, from one angle to another, just like that. All right, so yeah, that was it. Let's see the other part. Number 7, we are now given M and N. These are the ones that we have got, M and N. Giving your answer in standard form. So this is standard form here. Calculate Mn. So Mn is the product of M and N. Okay, that is your Mn, which is your M and your N here. So we just multiply 4 times 10 to the power of 6, whatever that we have here, we multiply to 2,4 times 10 to the power of minus 3. So remember, if you're multiplying in standard form, you just need to multiply these numbers together, 4 and 2,4. Okay, so you shall have 4 times 2,4. Then you multiply the x, these bases and their exponents together, 10 to the power of 6 and 10 to the power of minus 3. Okay, so if you multiply this, what are you going to have at the end? 4, that's 4 here, and 16. We've got 1 here, 4 times 2, which is 8, plus 1, which is 9. So we're going to have 9,6 since we've got 1 decimal place. Okay, so this is 9,6 multiplied by 10 to the power of these powers, they add each other. So it's going to be 6 and minus 3. So it's 6 plus minus 3, which is same as 6 minus 3. Remember, plus and minus, which is going to give us a 3. So that's it, guys. In standard form, you're done. As long your number or your answer is in standard form, there's no need for you to rearrange or do this and that. Just leave it like that. Okay. Then we move on to the B part, which is N over M. So it's the same thing here. We just need to substitute our N, which is, in this case, if you have to substitute, our N is 2,4 times 10 to the power of 3. This one, so it's 2,4 times 10 to the power of minus 3, sorry, over M. Our M is 4 times 10 to the power of 6. So that's it, guys. Let us reduce our values and see what you're going to have at the end. 4 into 4, that's 1. Into 0, into 2,4 is going to be 4 into 2. That's 0 here, into 24, which is going to give us 6. So we're going to have 0,6. Okay, so if we divide these numbers, we are obtaining 0,6. Then we divide these two together. So dividing these two together, what are you simply doing? We are going to subtract the exponents. So it's minus 3 minus 6. So it's going to be like this, 10 to the power of minus 3 minus 6. And minus 3 minus 6, that's minus 9. So it's 10 to the power of minus 9, like that. All right. But cross-checking on our answer, we are going to see that this answer is not in standard form. Why? The 0,6 is not between 1 and 10. This one is not between 1 and 10. So what are you going to do? You are going to convert that 0,6 to standard form, which is going to be 6 times 10 to the power of minus 1. Remember, you just move 1 comma to the right, which is minus 1 times 10 to the power of minus 9. Okay, then combine your terms. Since we are now back to this part of multiplying, so we are now doing this concept as what we did here, or this part where we are multiplying the bases are the same. Remember, we ended up adding the exponents. So that's the same thing that we are going to do. We are going to add the exponents, which is the powers here. So at the end, we are going to have something like 6 multiplied by 10 to the power of minus 1 plus, and minus gives us a minus. So it will be minus 9, which is 6 times 10 to the power of negative 10. All right, so that's it from the directed numbers. Remember, that's going to be a negative 10 there. Okay, number 8, we are given circle geometry. And we are given W, X, Y, Z is a cyclic quadrilateral. The diagonals are X, Z, and Y. W, they intersect at P. So this is your P here. And this angle at P, it's 43 degrees. So this is your P. Okay, and put an angle 43, 25, and 70 there. So that was the information. All right, so yeah, just make sure that you read your information properly. Okay, calculate A. X, Y, Z, X, Z, Y, so that's X, Z, Y. Okay, so let's locate our X, Z, Y. X, Z, Y, in this case, this is here, X to Z to Y, this angle here. That's where we are going to have our X, Z, Y. So I want us to see what is happening. These angles, they're actually subtended by this chord, X, Y, this one. the chord XY is creating an angle. As you can see here, it's creating an angle at W. This chord is creating angle at W, also creating angle at what? At Z, like this. So these two angles, they are equal. So if this is 70, this is also 70 degrees. Okay, so that was it, guys. Angles subtended by the same chord at the circumference are equal. So that's what we simply needed in this case. So these are the typical approach that you can actually use when answering these questions, all right? Then YXZ, or B here, we need YXZ. So where is our Y? This is our Y here, X to Z, this one. All right, so we need this angle here. That's our YXZ. Okay. So what are we going to have or to do in this case? Actually, there are so many ways that we can apply in this case. Okay, I want us to see something here. This angle that we are referring to here is actually the same as this angle that we have got here. Yes, it's the same, but does this give us anything? For now, it doesn't give us anything. Okay, so what am I going to do? This is what I'm going to do. I'm going to calculate this angle here at here, this one at P, this one, the one that is at P, that is direct on a straight line with what? With 43. Remember, this is a straight line. So we can simply calculate this angle at P by subtracting 43 degrees from 180. So 180 minus 43, we are going to obtain something like 137 degrees. All right, so this is 137 degrees here. So to find this angle now, which is the one that we want to calculate, which is our YXZ, all right, YXZ here. To find this angle, we are just going to subtract these two angles from 180 since we are in a triangle, and we know that angles in a triangle add up to 180. So we're going to subtract this 25 and this 137. Okay, so it's 25 plus 137 degrees. All right, so add these two. We are going to have 180 degrees minus from your directed numbers. If you add, you're going to have 162 degrees. All right, so 180 minus 162, which is going to give us 18 degrees. Okay, so this is 18 degrees, and it also means this is 18 degrees. Remember, I told you that these ones are equal from what? From the same chord, which is YZ. They are created by the same chord, YZ. So these two, they must be what? They must be equal at the circumference. Okay. Then the other angle that we are given to find, let's see here, is SXW. Okay, that is SXW, which is here, S here, X to W, this angle here. This is the one that we are simply finding. Okay, so as you can see, guys, this one is using the same approach that we talked about previously here of having an exterior angle. Remember, I described here about the issue of the exterior angle with the opposite interior angles. And it's the same thing that was happening on this particular question here, because we can see that from this triangle XAY to W here to X again, this triangle, this is an exterior angle. So to find this angle, we are simply going to add the opposite interior angles, which is 25 and what? And 70. So this is 25 plus 70 here, which is going to give us 95 degrees. Okay, so that is what we got from this one. It was going to give us 95 degrees. Okay, so remember we said this one gave us 80. Yeah, 80 degrees. Okay, so these are the angles that we had, guys. As we can see, it was pretty direct, as you can see. Let's move on to number 9. We are given the bearing of town B from town A is 141 degrees. Find the bearing of town A from B. So the first thing, guys, is to sketch your diagram. Okay. So A from, take note here, it's town B from town A. So you start where you are given from, that is at A. So we shall just have our North Pole at A. Okay, so this is our North Pole here at point A. So knowing that 141 degrees is actually above 90, but below 180 degrees. So maybe it's somewhere here. Okay, so then we just indicate this. Our angle is 141 degrees. Okay, so this is the angle at A. Then it goes to B. Take note, it's B from. So where it reaches here, that is where our B is going to be located. So at B, you just draw and North Pole when you reach that point at B. All right, like this, you just draw your North Pole at point B. So this is your B here. All right, this is where our point B is. So the question now is for us to find the bearing of A from, now we are starting from what? From B. So which means we are going to go to B from the north in a clockwise direction, just like usual, our three-figure bearing from the north in a clockwise direction to the line that reaches A, this one. This is the whole angle. And there's something that is happening. Remember, I told you guys these lines, they become parallel. Okay, so if this angle is 141 degrees, it means also this angle here is going to be 141 degrees. Why? From our alternate angles. So this is 100. It's a stretched Z, this one. It must give us a Z. Okay, so this is 141, this is 141. And we know that angles on a straight line, they add up to 180 degrees. So the sum of these two, that's our bearing. So we're just going to add 180 degrees plus 141 degrees. Okay, so that was it. If we add these two, we are going to have 321 degrees. Or you can maybe find this angle here, then you subtract this one from 360. That was another way. You simply find this angle, then you subtract it from 360, you've got the remaining angle. So that was it. So many ways, guys. B, we are given the interior angle of a regular, take note is a regular polygon, is 162 degrees. Find the number of sides of the polygon. Okay, so we want to find the number of sides or where we are given the interior angle of a regular polygon. So remember this one, guys, I told you there are so many ways you can work with the exterior angle, since you know that exterior angles, they add up to 360 degrees. You are given, this is an interior angle of 162 degrees. So it means your exterior angle, the one that is outside of the diagram here, you're going to subtract this from 180. So it's 180 minus 162, which is going to give us 18 degrees. Okay, so this is 18 degrees. And we know that it's a regular polygon, whereby this is going to be also 18 outside of the diagram. So each and every angle is going to give us 18. So to find the number of sides, we are just going to divide 360 divided by 18, since we know that angles, exterior angles add up to 360. So 18 into 36, that's 2, into 0, that's 0. So we're going to have 20 sides. So this polygon actually has got 20 sides. All right. Or we could have used our normal formula. Remember the formula to calculate each angle for a regular polygon. Each angle is given by n minus 2 times 180 degrees over n. This is each angle. Remember, n minus 2 times 180 is for the sum of the interior angles. But now, if you divide by the number of sides, you determine each angle in this case, and you are given each interior angle is what? Is 162 degrees. So you're just going to equate this formula to 162 degrees, just like that. Okay, so that's it. You can find your n here by just cross multiplying, but this is same as over 1, so you can cross multiply this side and see what you're going to have. So here 180 is going to multiply everything, which is 180 into n minus 2 is equal to n times 162. That's 162n. Okay, let's expand brackets. 180 times n, that's 180n. 180 times minus 2, that's minus 360, which is equal to 162n. Okay, so let us collect our like terms. 162 to the left-hand side is going to be 180n minus 162n, which is equal to 360 degrees. All right. Now let's subtract 180 minus 162. That is the one that gave us 18. So 18n is equal to 360 divided by 18. Divide by 18 here. So our n is going to be what? 2 here, and this one is going to be a 0. So n is going to be 20 sides. So this polygon has got 20 sides, as you can see from either way. But as you can see, this one gives us a lot of working. But yeah, you can just choose which method is best for you. Okay. Number 10, we are given a sector. It's actually a circle, the complete of a circle, but here you are given part of a circle, which is a sector. And we are given that A or B, the one that we can see, is 7/15 of the circle center O. Okay, calculate A or B. So this is your A or B, which you are given as 7/15 of what? Of the circle. And we know that the complete angle must give us what? Must give us 360 degrees at this point here. So since AOB is 7 over 15, therefore our AOB is going to be 7 over 15 multiplied by 360 degrees for the angles at a point, okay? Angles at a point, they up to 360. So you can actually work with this concept. Okay, so this one is going to give us 168 degrees. If you work it properly, guys, I want you to divide and see if you're going to obtain the same thing. All right, so that was it, guys. That's our A or B, which is 168 degrees. Then we move on to B, the radius of the circle. Calculate the radius of the circle whose area is 154 square centimeters, taking pi to be 22 over 7. So this is just a separate question whereby we know that the area of a circle is given by pi r squared, and we are given the area is 152. So 152 is equal to pi, which is 22 over 7. Take the pi that you're given here, that is 22 over 7 times r squared. Okay, so we have to find the value of r here, which is, how are we going to find our r? We can cross multiply, because this is same as over 1. So cross multiply this, that's 152. 154. All right, this is 154, guys. Okay, so this is 154 here, not 152. So this is 154. Okay, so we're going to multiply that 154 and 7, which is going to be 154 times 7. Okay, is equal to, here we are going to be left with 22 r squared. So you can divide by 22 both sides here. Divide by 22 both sides, so this can cancel. So r squared is going to, you can reduce, guys, by any number until you get the exact value here at this, but here it's 7, then 7 times 7, which is 49. Okay, so to find r here, you can just introduce the square root both sides, square root here, square root there. So that means our radius is going to be 7. Remember, it's only a positive value that you use. So that will be your radius, square root of 49, which is going to give us what? 7 centimeters. So that's it. All right. And yeah, this is what you just need. Number 11, we are given Taurai is X years old. Okay, so we've got Taurai here, which is X years old. Rikomborero, your brother, is 9 years older than her. So this one is 9 years older. So Rikomborero is 9 years older. So it's 9 plus what? X. That is 9 years older. Their father is 3 times as old as Taurai. Okay, so their father here is 3 times. 3 times means 3 times like this. The X, because Taurai is X years. So it's going to be 3X, all right? And their mother is twice. Twice is 2 times. So it's 2 times what? Rikomborero. So it's going to be, their mother is 2 times the years of Rikomborero, and Rikomborero is 9 plus X. Okay, so these are the ages of this family. Now the question on A is to write down and simplify in terms of X an expression for the total age of the 4 members of the family. Okay, so what is the total now? So the total, you just need to add Taurai, which is X, plus Rikomborero, which is 9, plus X, plus their father, which is 3X, plus their mother. But the mother now, you have to expand the bracket, so it's 2 times 9, which is 18, 2 times X, which is 2X. So let us collect like terms. X, the same as 1X here, so it's 1 plus 1, which is 2. 2 plus 3, which is 5. 5 plus 2, which is 7. So we're going to have 7X. We add the numbers, we've got 9 plus 18, which is going to give us something like 27. All right, so this is going to be 27. So this is the total number of years of the whole family that we are given, of these 4 members that we're given, the 2 guys and their mother and father. Okay, then calculate this, given that the sum of their ages of the 4 members is 139. So now we are given the total, which is this one that we expressed in terms of X. Now they gave us the numerical value to say it's 139. So find the value of what? X. What am I going to do? I'm just going to equate the total in terms of years, which is 7X plus 27 then I equate that one to the total number of years. In this case is what, 139. So this family is giving us a total of 139 years. So that's it. So that means from this part we can transpose to make x the subject. So 7x is equal to transpose. This is going to be a negative 27 on the other side of the equation. So 139 minus 27, yeah, subtract properly. There is going to be something like 112. All right, divide by 7 here. So x is going to be 7 into this, that's 1. And we've got a remainder of that is 5, that is 4 in this case. Okay, so that's 4, then 7 into 42, which is going to give us 6. All right, so that's our x. So in this case, our x is going to be 16. So take note, you are just asked to solve for x, or to find the value of x, that is to solve. So that's it. Number 12, you're given the scale of a map, which is 1:1 million, the one that you're given, and from the scale, we are asked that in this case, the length, okay, find the length in this case, that is your A, find the length in centimeters of a line drawn, of a line on a map which represents a road that is 160 kilometers. Okay, so here we have to play around this conversion. Remember, guys, I told you that this conversion means 1 centimeter as to 1 million centimeters. That is what this conversion means. So how are you going to do it? You convert this to meters, then to kilometers if you want, or you can just use this conversion, since we know that in a kilometer we have got 100,000 centimeters. So to convert this to kilometers, you're just going to divide by 100,000. So if you divide this by 100,000 here, if we divide by 100,000, you're going to remove these zeros here, these 2 zeros, this like this. So you're going to remain with 10 kilometers now. So it means you just converted this to kilometers, since you need your length in kilometers. And this is your scale factor. And we can use our scale factor since we are calculating what length. So there's nothing wrong about this. We just have to maintain our scale as it is, to say that a centimeter represents 10 kilometers. So that is what you're asking yourself. If a centimeter represents 10 kilometers, what about 160 kilometers? What is it going to be represented on the map? So this is 160 kilometers. What are you going to have on the map? So as you can see, more, it's going to be 160, divide by 10, whatever that we get, we multiply to 1 centimeter. All right, so let's do the division here. Is 6, yeah, that's 16. So it's going to be 16 times 1, which is 16 centimeters. Okay, so it means this length is going to be 16 centimeters, so that we can see 160 kilometers on the ground. Okay, so that was it. Then B, the actual area of the piece of land which is represented by 2,64 square centimeters on the map. Okay, before we talk about this, we need our answer in square kilometers. And what are we given here? Area. So which means you have to work with what? With area factor. Once you hear of this area, think of area factor. Okay, and I told you guys to find area factor. You can actually find area factor from scale factor, where area factor is equal to the scale factor squared. So you square the ratio that you are given, which is this one. This is your scale factor, 1:10 kilometers. Since your answer is needed in square kilometers here, so you're going to start where there are what? Kilometers at this stage, okay? So 1 centimeter S/10 kilometers. So this is S/10 kilometers here. What are we going to have at the end? Then we square. Okay, so if we square this, we now have our area factor, which is 1 squared remains as 1. So it's 1 square centimeter S/10 squared, which is 100 square kilometers. Okay, so this is our scale that we are going to use for area now. So this is what we have got. So we mean 1 square centimeter on the map represents 100. That is what it means. It represents 100 square kilometers on the ground. What about this one that we are given of 2,64 square centimeters, which is on the map? So remember, 2,64 is on the map and it must be under square centimeters. What are we going to get in square meters? That is the question. All right. So as you can see, this one is going to be a more, which is 2.64 over 1 multiplied by 100. Okay, so multiply by 100 here, that's going to be 264. All right, something like this, which is now in a square centimeter. So that is what you're going to see on your map. You're going to see, sorry, this is square kilometers, sorry, because we are multiplying to square kilometers here. This is 100 square kilometers, sorry for this. So this is square kilometers. Okay, not square centimeters, but square kilometers. Okay, so that was it, guys. Your area in square kilometers, you are done. Number 13, we are given a function there. Find f of minus 1 from that function. So remember, guys, f of minus 1, simply substitute minus 1 in place of x. So f of minus 1 is going to be minus 1 squared minus 7 into minus 1 plus 5. Okay, so this is going to give us minus 1 squared, that's minus 1 times minus 1, that's 1. Minus 7 times minus 1, that's a positive 7 plus 5. So we're going to add these 3. And if we add properly, that's 8. 8 plus 5, which is 18. Yeah, this is going to give us a 18. All right. Then B, the values of x for which f of x is equal to minus 7. So we're given f of x. What is our f of x? This is your f of x here. This is originally your f of x. Now it is equated to minus 7. So you're saying x squared, which is your f of x here, x squared minus 7x plus 5, like this. This is our f of x. You equate that one to minus 7, like this. So by equating to minus 7, we have created an equation, and as you can see, this is a quadratic equation that we have. And whenever we are given a quadratic equation, let us try by all means to make sure we have got the format of the equation, which is ax squared plus bx plus c is equal to 0. This is the format of a quadratic equation. So, which means we have to transpose this negative 7 to the other side of the equation, and it becomes what? A positive 7. Okay, so we can add 5 plus 7, which is 12. So we are going to have x squared minus 7x plus 12 in this case, which is equal to 0. Okay, now let us solve. You can choose to use factorization, quadratic formula. I don't know which best method for you, but yes, since the quotient of x squared is 1, I'm just going to utilize a factorization, and it becomes much easier because I just know here I'm going to insert x here, then we focus with the constant, which is minus 12, and we need factors that are going to give us minus 7. So which are the factors of 12 that we are going to add, and they give us a negative 7. So definitely this is negative 4 and negative 3. If we multiply this, we get positive 12. If we add this, we get negative 7. So we got from minus 4 and minus 3. So that's it, guys. Either one bracket must be equal to 0 here. So either x minus 4 is equal to 0, or x minus 3 is equal to 0. That is what it means. So x will be equal to what? X will be equal to 4, or our x is going to be what? Negative 3 to this side of the equation is going to be positive 3. Okay, so that was it. From this part, we just need to solve the equation as usual. Okay, number 14, there's a bag which contains red, blue, green counters. Okay, so these are counters, all of which are identical except for color. A counter is picked at random from the bag, its color is noted, and then it is replaced. So this one is with the replacement. So you take a counter, then you replace it back. So it's like you haven't done anything. You took it, then you replace it back. So that is with replacement. And you are given the probability of picking a red, which is 0.2. So probability of having a red is 0.2 here. The probability that it is blue is 0.5. So given the probability that it is blue, which is 0.5. But take note how many counters were we given. I mean the type of counters we had: red, blue, and green. So the green is not there. So which means we can find the probability of green here. Where are we going to find the probability? Remember, guys, I told you that on your probability, whether you're given a tree diagram, you have got red here, you have got blue here, you have got green. All probabilities, they add up to 1. If you add everything, that you are given, they must give you a 1. So since we are given these probabilities, we are just going to subtract these 2 from 1, which is 0.2 plus 0.5. So if we subtract these 2, which is going to be 0.7 here, right? Let me erase this. So it's going to be minus 0.2 plus 0.5, that's 0.7. And if you subtract, you're going to obtain something like 0.3. So this is the remainder part that is going to represent what is in green, which is 0.3. So that if we add these 3, they must give us a 1. That is what a probability means. Probability of everything that we are given must give you a 1. Okay. So here it was just a matter of knowing what is happening. Let us see the first question. Calculate the probability that the counter picked is either blue or green. So take note of these words, guys. I told you either or you add. Okay, when you're given this, you just add. So the probability that is either what? So this is item A. So we need the probability that is either green or what? Green, either blue or green. Okay, so this is blue or green. So we're going to add the probability of blue plus the probability of green. That is what either mean, you add. Okay, so the blue is 0.5. So that's 0.5 times, okay, why am I multiplying now instead of adding? Okay, so I'm going to add here, which is plus the probability of green. We already calculated the green here, which is 0.3. All right, so that's it, guys. If you add 0.5 plus 0.3, you're going to have 0.8. So this is the probability that either is what? Either is blue or green. So that's what you're going to have at the end. And the B part, we are given 2 counters are picked at random, one after the other, with replacement. Okay, calculate the probability that one is red and the other is blue. Okay. Actually, when you pick twice like that, you're supposed to have a tree diagram, guys. This is what you're supposed to have with these 3 like this, where you're going to have the first pick. Like I'm just going to illustrate what you're supposed to. I'm not going to put this diagram as it was, guys. There's no need for us to do that. We've got red here, we've got blue, we've got green. Then you pick again. This is what you're supposed to have. This one, it creates 3 branches. This one, it creates 3 branches, as we can see here. Okay, then we are done. We move on to this one. Blue, it creates 3 branches. The one for green, it creates 3 branches. This is what we're supposed to have. Where we have got red, blue, and green, and so on. Red, blue, and green, red, blue, and green. This is what we're supposed to have at the end. But you see that, guys, there's no need for us to even do that. If you know this well, there's no need for you to do this, because you need where there is red and there is blue. So definitely it's only from the branch that has got red. So we can have the red from the branch that has got red, which means we can have it from red to blue like this, or we can just have it from blue to red. That is the only way we can have a red and blue. We can't have red and blue from a branch that has got green, which means green has got nothing to work here. So you see, so which means that is what we have. So there's no need of that. Yes, we can do that. The tree diagram is best for you, but you can actually minimize those workings. So for you to have these 2 colors here, which is red or the other one that is blue, it can be this way. We can have red followed by blue, or it can be what? Blue followed by red. That is what it means. There's no way that we can have blue and red. These are the only conditions, okay? So there's no need for the tree diagram. And the other thing, why I'm saying there's no need, because this is with replacement, where I told you guys with replacement, the probability that you start with is the same throughout. So your red is going to be 0.2 throughout. Everywhere where there's red, 0.2. Everywhere where there's blue is 0.5. Everywhere where there's green is 0.3. That is what it means. Everywhere is going to remain like this, okay? So that means here we are going to have red, blue. We multiply these 2 together, red and blue. So what was our red here? Our red was 0.2, our blue 0.5. So we multiply 0.2 times 0.5 like this. All right, then we move on, plus blue, red. Remember, this is your blue. which is 0.5, and your red, which is 0.2. So you multiply these together. All right, so multiply together properly, you're going to obtain 0.1 plus, obviously this one again is 0.1 because these two are just the same. So if we add 0.1 plus 0.1, we are going to obtain 0.2. All right, so that was the case. Guys, like I said, some of these questions we don't need to work a lot, guys. Revise as much as you can so that you minimize working while you're in exam. Okay, 15 factorize x squared minus, okay, this question paper was one of the easiest, as you can see, guys. I think, yeah, this was one of the easiest. I don't know, but on the look of things, okay, so that was it there. From a difference of two squares, okay, then the b part, given that x minus y is equal to 4 and x squared minus y squared is equal to 20, find the values of x, the value of x and the value of y. So these are now simultaneous equations. Okay, I'm just going to take advantage here from this one. I am given that x minus y is equal to what? 4. Also, I am given that x squared minus y squared is equal to 20, where I know that this x squared minus y squared, I'm just going to use this method so that it becomes easier for us. Since we already have this one, x squared minus y squared, this, we already found that x squared minus y squared here is same as what? Is same as x plus y, x minus y. I'm going to put this one as x plus y, x minus y like this, and equate this one to 20. Okay, why am I doing this? Because I have got the value of x minus y. X minus y, the whole of this x minus y here gives us or is equal to 4. So it means I can substitute in place of what? In place of x minus y here, I can substitute with 4. So it's going to be 4 into x plus y like this, which is equal to 20. So I can just divide by 4 both sides. So why am I doing this? I'm avoiding to work with a quadratic equation, so that I will just work with a linear equation, because this will be 5 here. So as we can see, we have formulated another equation of x plus y. So now I'm going to use that one with the first one of what? Of x minus y, which was for these two. So I'm now going to use these two, and they are linear equations here. So I have avoided to work with a quadratic. Okay, so this is how we can avoid to work with a quadratic for good. Okay, so now since you are working with a linear, guys, you know you apply whatever method that you're going to use. I don't know which one is best for you, but here I'm just going to use elimination. How do I eliminate x? Subtract the second equation from the first equation. By doing this, I can eliminate x here because it's x minus x, which is a 0 here. Then this is minus 1y minus 1y like that. So it's minus 1, which is negative 2. Y is equal to 4 minus 5. 4 minus 5, that is a negative 1. Then we can divide by negative 2 both sides, so that we can have the value of y in this case. And this is going to give us 1 over 2. So with this value of y, I'm just going to substitute into n of these equations, just any. I can choose the first one, x minus y. In this case, y is a half, so x minus a half is equal to 4. All right, that's a 4 here. So x minus half is equal to 4. Then I can just transpose the minus half to the right-hand side of the equation, and that becomes a positive half. Okay, so what will be the value of x from this one? Remember, if you're adding a whole number and a fraction, you just combine 4 and half like that. That's how you do it. Just like we've got 4 loaves and a half loaf, you combine, we've got 4 and a half loaves, isn't it? That is the idea there. So that is what we get. So these are some of the typical questions of paper. I think I worked another type of a question like this from the one of the question papers that we get. So I think you can use this one and that one and see the similarities that we have, and you see that it's just one thing there. Okay. For number 16, we are given a right angle triangle, and it's an isosceles triangle, as you can see, as we have got here at point A, the line of symmetry to D, they've got 90 degrees at D there, and we are given the area of the triangle, which is 108 degrees. So that is the area of the triangle, and that's it. Okay, so the first question is to find A, which is AD. So let us cross check what our AD represents. This is our AD. This one which is actually our perpendicular height. So this is the perpendicular height of the triangle. So we are going to use the area because we are given area here. So that is the best way that we could have used, because we are given area, and we know that area is equal to half base times perpendicular height. This is a right angle triangle, and the area is 108. So 108 is equal to the half times the base. Okay, what is our base here? This is our triangle, and the base is this whole side from B to what? From B to C, which is 24. So that is your base. You take that whole side as it is. So it's going to be half of 24 times the height now, which we do not know. Okay, so let me just rewrite here. So this is 24 times the height. Okay, like this. So now you need to find h. What can we do to find h? You can reduce 2 here, that's 1. 2 into 24, that is 12. So you can reduce by 12 both sides by dividing by 12. Since we are going to have 108 is equal to 12 times h, which is 12h. So you can divide by 12 here, by 12 there. So this can cancel. So h is going to be 12 into 108 is going to give us something like 9. Okay, so this is 9 centimeters, which is our height here. So that is our AD, because we said AD is the height. Okay, so it means in this triangle, there is a height here of 9 centimeters. Okay, that was it. And calculate AC. Okay, how can we calculate AC? I want you to see that if you are to cross-check here, we can, since this is an isosceles triangle, this line, the perpendicular line that we just found here, it divides this side into 2 equal parts, which means from B to D, it is the same as from D to C. We are going to have equal length. So you divide by 2 by 2 here, 2 into this, that's 1, 2, 12. So you're going to have 12 centimeters here, 12 centimeters here. All right. So since I want to calculate AC, I'm going to utilize this triangle here, ADC. Okay, so using triangle A, D to C, we have formulated a right angle triangle where our Pythagoras theorem can play a major role, because we know that from our Pythagoras theorem, A squared, H squared is equal to A squared plus B squared. So we're going to add, in this case, your B squared, where H is the hypotenuse of the given triangle, which is our hypotenuse, which is AC. So it's going to be AC squared is equal to the hypotenuse AC. That is what we got. Then A and B, which are the shorter sides in this case, and the shorter side is 9 here. That's 9 squared plus another shorter side, which is 12. So it's going to be 12 squared. Okay, so that's it. It's a plus here. All right, so we've got AC squared is equal to 9 squared. That's 9 times 9, which is 81 plus 12 times 12. You remember, this is 144. So you can add. After adding, I got something like 225. Okay, so this is our AC squared. But we need AC, not AC squared. So what are you going to do to find AC? Introduce the square root both sides. That's the square root here. The square root on that part, all right, that's our AC. In this case, is going to be 15. The number that multiplies itself to give us 225 is 15. So which means AB is 15, AC is 15. Remember, these two sides are the same, they are equal. So if that one is 15, also the other one is going to give us what? Is going to give us a 15. That is what it actually means. All right, so that was it, guys. Then number 17, we're given a cross-section. This is a cross-section of a swimming pool that we have got, and the question was to calculate the area of the cross-section in square meters. So these units are in meters. We put 1 meter, 2 meter, 25. These are meters here. All right, so how we're going to find the area? This is a trapezium. So we know that area of a trapezium, guys, is given by what? Half sum of the parallel sides multiplied by the perpendicular height. So A and B are the sides which are parallel times height, whereby this 1 meter here and this 2 meter are the ones that are parallel. These two sides, they will never meet. So which means our area is going to be half of 1 plus 2. Whatever that we get, we multiply by the height of this trapezium, the one that we are given, which is 25. Okay, so that is 25 there. So that was it, guys. You just have to be very, very clear on your working. All right, so that's it. And we can now simplify further, which is going to be half multiplied by 1 plus this, which is 3 times 25. Okay, so if we add 3, if we multiply 3 times 25, that's actually 75. So this is 75 over 2, and if we divide, we are going to have 37,5. Okay, this is our area in square meters, which is 37,5. Okay, then on B, we are given that the swimming pool is 10 meters wide. It means from this cross section to another cross section, there's another cross section. We don't know exactly where this cross section is located, but to that cross section that we are going to have there is a distance of what? Of 10 meters to that cross section. So how do I now find the volume? Okay, so volume is equal to area of the cross section times the distance between the cross section. Okay, so that is your volume now. So volume is equal to the base area. So this one is actually base area or the cross-sectional area. So this is base area or cross-sectional area times the height, which is the distance between the cross sections. Okay, so that's it. So already I have got this base area, which is my cross-sectional area here. I've already calculated this before. Remember, we got 37,5 there as our cross-section. So we're going to have 37,5 times the height now to find the volume. Okay, so the height now is the distance from one trapezium to another, which is this one of 10 meters. So if we multiply this, we have got our volume, which is 375 cubic meters. Okay, remember volume is measured in cubic units. Okay, so that's how you simplify your volume, guys. As you can see, it was pretty clear. Number 18, we are given the logarithm of 2 in base of 3 in base of 5. This is log 2 base 5, sorry. And this is log 3 base 5, which is 0.683, and this is 0.431, and you're asked to find the value of log 1.5. Okay, log 1.5, guys, you know this is 3 over 2. So this is going to be log 3 over 2 in base of what? In base of 5. Okay, from our laws of logarithm, what actually happened for you to divide these numbers? You were subtracting logarithms, okay, from this law, log m over n. We know this one was taken from what? From log m minus log n, provided that the bases here are the same. So in this case, that's what you're going to have. So you're going to have log 3 in base of 5 minus log 2 in base of 5 from our laws of logarithms. But here I've got this value, log 3 base 5. I've got the answer here. So I'm just going to substitute 0.683 minus log 2 base 5. I've got the answer here. Log 2 base 5, I've given this value, which is 0.431. Okay, so I want you to subtract properly, guys, using your techniques of subtraction. You're going to obtain 0.252 there. All right, so that was it. Direct, guys, as you can see. All right, then we move on to the B part, which is log square root of 3. So first, let's get rid of the square root. From your laws of exponents, we know that square root of x was taken from x to the exponent of what? Of a half. So the same with 3. It means this square root of 3 is going to be log 3 to the exponent of a half in base of what? 5. Drop the exponent that you are given, and what's our exponent here? That's a half. Yes, we're going to drop this exponent, which is a half log of 3 in base 5. So what does it mean? I have got the value for this log 3 base 5 here. So I'm going to substitute as a half multiplied by log 3 base 5. And this is my log 3 base 5, which is 0.683. Okay, so this is what I'm going to do. Let us divide 2 into 0 here. That's a 0.2 into 6, that is 3. 2 into 8, that is 4. 2 into 3, that is 1 into 3, and we've got a remainder of 1. Put a 0 here. 2 into 10, which is 5. Okay, so that was our log square root of 3 in base of 5. Okay, so that was it. 19, we are given the vector. Okay, vector AB, vector BC, then we want to calculate vector AC. So how do you find vector AC, guys? It's simply from your, this is a route from A to B, from B to C. So you just have to combine them. So it's AB plus BC, this one. Okay, so this is AB plus BC. Okay, so let's add our AB. We are given AB is 2, 4. Okay, plus BC, B to C, which is minus 8, 6. All right, so that's it, guys. As you can see, this one I think is almost 1 mark. 2 plus minus 8, plus and minus gives us a minus, so it's 2 minus 8, which is negative 6. 4 plus 6, which is a 10. Okay, so that's what you're going to have as your vector AC here. which is negative 610. Okay, then item 2, we are given on item 2, there is an equation that we are given from this part. So we are given that 2cx is equal to bc. So find the vector what? Cx. So this is what I'm going to have. But remember, 2 is just a scalar. This one, it multiplies everything in the vector. So how do you remove a scalar? You just divide by it both sides, divide by it both sides, just like a normal equation. So that's it. The moment you divide by this scalar, it is going to be Cx is equal to, this is a vector, so you don't write it as BC over 2 like this, you write it as half BC like this. All right, so this is what you're going to have from this vector that you are given. Okay, sorry for this call, guys. Okay, so it is going to be half of BC. That is what you're going to have like this. Just like this one, let me illustrate from this case here. Just like 4 over 2 like this. To write 4 over 2 simply means half of 4. That is what it means. All right. So if it is even, it can be x over 2 like this. It means half of what? Half of x. That is what it means. Okay. So that is it, guys. So that's your Cx. Now you can substitute your values since we are given this BC. So it's going to be half multiplied by vector BC. Back here, we have got our BC. Remember, our BC is given as minus 8, 6. So we're going to multiply by negative 8, 6 here. All right, so that's it. Half of negative 8, that is negative 4. Half of 6, that is 3. So that's our vector Cx at the end. Just like that, you're done. Okay, then let's see the other question now on B. We are given a point P. And this question, guys, I think we have worked this one a lot of times, a lot of times. Okay, anyways, let me work on it. We are given the point P is minus 3 to PQ is 3 minus 5. Then find the coordinates of what? The coordinates of point Q. All right, so remember, guys, I told this one, you just extract from this vector PQ here. How did we end up with the vector PQ? We know that it was taken from what? OQ, last part here, which is OQ minus OP. That is where our vector was taken from. And all we just need is to substitute what we have. PQ, do we have PQ? Yes, we have got PQ. This is 3, negative 5 is equal to OQ. So OQ is our position vector, the one that is going to give us Q. So we do not have this one. So we just have to rewrite as it is minus OP. Where do you have OP? From the point P, but you write it as a vector now because it's from the origin, which is negative 3, 2 like this. It's now a vector. Okay, so to find OQ is simply finding Q. So what means I'm just going to transpose this negative to the other side of the equation so that it becomes a positive here. All right, it's going to be a positive, this vector. So for 3, negative 5. Okay, I forgot to change the mark, it's fine. So this one is a negative, so it's going to be a positive. And we've got negative 3, 2, like that. So these numbers, they do not change their signs. What changes the sign is this part that we have taken. Okay, the whole of the bracket, not what is inside the bracket, which is the vector there. So it's going to give us vector OQ. And if you are to simplify, these are now directed numbers. As you can see, guys, 3 plus minus, plus and minus is a minus. So 3 minus 3, that's a 0, this one. So you're going to obtain a 0 here. Okay, minus 5 plus 2. So this is negative 5 plus 2, which is simply 5 minus 2, that's 3. And we take sign of the bigger number, which is negative 3. So revise your directed numbers also, guys, so that we become faster in doing this. Okay, so this is vector P or Q. But what do I need here? I need a point Q. So what am I going to take from this point, from this vector? Therefore, our Q as a point, we're just going to write this as coordinates, which is 0, minus 3. Okay, so that's what you even did here. If you cross-check here, you have point P, it was minus 3, 2. But we wrote this one as a vector like this one, as a column vector. So which means we can take it from a column vector to writing it back as a what? As a point like what it was before. So it's the same thing like what happened with our Q here. We are given the position vector, so we can rewrite from position vector now to a point. That is what it means there. So you have to write your answer as a point, as you can see here, as a point, not a vector. All right. Let's see, number 20, we are given the Venn diagram. In this type of a question, guys, you're supposed to analyze. It's not like it's a direct person, this one. It's not a direct person. You analyze from the information that you are given, okay? So in this case, we are given on number 20, that is XY, and we are given this. So these terms here, they just assist you to know that is the intersection of so forth or so forth, okay? What was important is this information, the number of elements in universal set, number of elements in X, and number of elements in Y. Okay, so the first question was to find the smallest possible value of Z. Okay, what does Z represent? Z, these are the elements which are not in X, and also they are not in what? They are not in Y. Okay, so for you to have the maximum value of Z like this one, it means this condition can only be taken if these sets are subsets. That is where we can have the minimum or the least value of what of this part where when they are separated. Okay, it's not this one. This one is for maximum. Sorry, I want minimum. So for minimum values, these sets must be what? Must be separate. That is where we can end up with minimum less values which are left outside of what X and Z. So it means your X and Z can be treated this way. If they are separated, if X is here and X and Y, so if your X is here with its equivalent elements, remember the elements which were in X, we are given that in X here, we have got what? 55 elements. So 55 here, and Y has got what? 32 elements. This is what we have like this. That is the only condition that is going to allow us to have the minimum value of Z, because Z is what representing what is outside. That is what a Z simply means. There is not like you're going to use that diagram. It simply means Z is a number outside, okay? And for you to have the list, it is from what? From disjoint sets. Disjoint sets, which is going to be the opposite now when you take from what? From the joint one, which is going to give us the minimum, the maximum. So for minimum, they must be disjoint like this one. But remember that in the universal set, there are how many elements? There are 150 elements in the universal set. So which means our set is going to be 150 minus what? Minus this total of the two. Okay, so we've got 150 degrees here. Let me just put it this. So our Z is going to be 150 for the total minus this, because now they are acting separate. So you can add what is in X plus what is in Y separate like that. Okay, so it's going to be 150 minus 87. Okay, so this is going to be 87 degrees. And if you subtract this, we're going to have 63. All right, that's where we can have our maximum. So this part of sets, I need you to revise this part of sets because it's very, very important for you to understand these tricky terms that you are given there. Okay, then let's see the largest value of what? The largest possible value of V. Where is your V located? V is on the intersection here. Okay, so for you to have the largest value of the intersection, your sets must be subsets. That is the only condition from subsets like this. That is where we are going to have the largest possible value of the intersection. And it can only be a subset if this set Y here is a subset, because it's the one that has got fewer elements than X. As you can see, Y has got 32 elements and X has got what? 55 elements. So that is the only condition that can give us a maximum like this, where this one becomes what? A subset like this one, where our Y, the one with the smaller values, this one, definitely is the one that is going to be what? Inside here. So this is your Y here, and this will be your X. Just like that. And remember that in Y, we have got how many elements? We have got 32 elements here. So that is going to be the one that you take for the largest possible value. So this will be 32. Yeah, I think this one I have to explain as a different part, because maybe you can understand what is happening, because maybe you can understand. Okay, then on the C part, what is the value of W if U is equal to 45? Okay, so you're given that U is 45, then what is W? So this one now is the one that you come back to this diagram and substitute here on your diagram. So let us substitute on our diagram. So what does it mean? Remember, we are given that in this case, U is 45. So this is our U here, which is 45. But we are given previously here that in X, how many elements are there in X? There are 55 elements, okay? So to find this V, we are going to subtract 55 because here there are 55, these ones, okay? So it's 55 minus 45, which is going to give us 10 here, okay? And remember that in Y here, we have 32 elements. In set Y, we've got 32 elements. So to find this W is going to be 32 minus 10, which is 22. So this is your W here, which is going to be 22. Since we want to calculate the value of W, so our W is going to give us 22. Okay, so remember in your set, guys, they are saying to find the intersection, because you've got this X, so you can subtract, find the intersection, you subtract what is on the intersection to find the part of what? Part of W. Okay, so that was actually the type of person that you play around. Yeah, these are play around persons, as you can see. Number 21, we're given during a sale, a shop reduced all its prices by 20%. Calculate the original price of the article during the sale. Okay, so for which was now for sale, for which was now sold, which was sold during the sale for 440,000. Okay, so what was the original price? So take note, guys, we reduced it by what? By 20%. So if we reduce by 20%, it means we are now at 80, because remember, percentage is at 100, then we subtract 20%. This is what we removed. Reduce, that is subtract, okay? So which means we are now at 80%. So at 80%, that is where we managed to buy this particular item for what? For 440,000. All right. So what about 800% before we reduced this price? What was the price exactly? So this is what you're asking yourself. So you can use your proportion, since as you can see, this is going to be more. So it's 100 over 80 here, 100 over 80 times 440,000, like that. All right, so you don't write on this space, guys. Yes, because of the space that I'm having, but you are not allowed to write on that space. Okay, so that's it, guys. You simplify here the zero and what, you cancel everything. You're going to obtain something like 550,000. I want you to work out this, guys. Yeah, perfect your multiplication, guys. This is why I want you to perfect your multiplication. So I want you to multiply and see if you're going to obtain this here. Okay, so that was it. Then the B part, we are given that on a particular day, the bank bought British pounds at a rate of 1 British pound for 35,000 Zimbabwean dollars. Just imagine, guys, how our economy is. Okay, anyways, that was on that particular part where we have given a pound was being bought, and then when they are selling it, now they are selling each pound for what? For 40,000, which means they are gaining 5,000 there as a profit. Okay. Then the question was for us to calculate the amount of British pound bought. So we are using the rate of buying this one. We bought this one at 1 British pound, was being bought with what? With 35,000 Zimbabwean dollars. So this is 35,000 Zimbabwean dollars. So now, what about for this 150? It's what? Not 10 million 500,000. 10,500,000 Zimbabwean dollars. How many pounds are we going to buy? That is the case. So as you can see, guys, it's going to be more simple proportion here. You divide these two. So it's 10,500,000, whatever that you have got there, divide by 35,000. Then you multiply by a pound. So that was it. So you multiply to a pound there. Okay, so I want you guys to divide everything there. As you can see, the zeros there, they will cancel everything. So you've got the zeros there, the zeros there. So if you want to reduce, we are going to obtain something like 300 pounds. So that's what you're going to have at the end. That is 300 pounds in this case. Then the item 2, we are given the amount in Zimbabwean dollars that you are going to have received by selling 112 pounds from this part. Okay, so what we are going to have is to use the rate now of selling. Okay, so we are going to back to the selling here, where we are selling. Remember, when we are selling, the selling price, they were now, so they sold these ones at what? At £1 per $40,000. Okay, so it's a pound per 40,000. So we're going to say we're now selling, it's a pound sold at what? At 40,000 Zimbabwe dollars now. So it's 40,000 Zimbabwean dollars that you're going to have. And what about now if we had to sell 112? So this is what was sold, 112 pound. What am I writing like this, guys? Look where I'm writing my pound at. It's supposed to be there. Okay, it's fine. So we're going to have 112 here pounds. Okay. So what are you going to have in dollars? How much? So it's going to be more, as you can see, guys. It's more. So it's this one over this one. 112 over 1 multiplied by 40,000. So that's what you're going to have. You multiply by 40,000. And if you multiply by 40,000, you're going to obtain something like $480,000. Okay, so remember, you want to get Zimbabwean dollars here. So it's $480,000. Okay. So that is what we are going to have in this case. All right, so that's it. We move on to the 22. We are given here is a velocity time graph. We put velocity in meters per second. That's what we have. And the diagram shows the velocity time graph for a particular journey. Calculate the distance traveled in this case. Okay, so we need in 30 seconds for the first 30 seconds. Okay, so for the first 30 seconds, if you have to cross-check this, what we have got here, this is 30 seconds here at 30 here. Okay, so we need the distance under the graph. So as you can see, guys, we've got two shapes that are very common. This one here at this stage here, we've got, so let me change the way I'm sitting here. Okay, so this is here a triangle that we can see from 0 to 10, 20 to 10. This one, that's a triangle. So we're going to use this one, the first shape, the second one, which is a trapezium here. Okay. So you've got a triangle and a trapezium. These are the two shapes that you're going to work with. Okay, so remember distance, guys, is area under the shape. So there it was a triangle and a trapezium, whereby we know distance. Area of a triangle, half base times perpendicular height. Guys, this software now needs me to be slow while I need to finish this paper now. Okay, anyways, we've got half base times perpendicular height plus the one for the trapezium, which is half sum of the parallel sides multiplied by the perpendicular height in this case. All right, so let's just work it here. So that's our distance, which is half base times perpendicular height in this case. So the base in this case is from 0 to 20. This is the base here from 0 to 20. So we put 20 here, multiply by the height. And our height in this case is 10 from this point to this point here. That's a 10. That's your height there. All right, so you multiply by 10. Okay, so that's it. The first one, guys. Okay, let's see. Plus half sum of the parallel sides now for the trapezium. So the trapezium here is from this 10 here, this 10, and the other side is this one that goes up to here to 20 here. We are tracing where the diagram is at this point 20. So you are tracing this. This is your trapezium, this one. Okay, something like this one. Okay, so you have got these lines which are parallel. Okay, so this is 10 and this is 20 here. Okay, so those are the sides, half of 10 plus 20. Okay, so it's going to be half of 10 plus 20 times the height. The height is the difference between these two from 10 to 20 here. This is your height. So it's from 20 to 10, 20 to 30, which is 10. All right, so that's it. Half base times perpendicular height. Half of 20 here is 10. 10 times 10 is actually 100. Then you can combine here, it's going to be 30. Half of 30 here is 15. 15 times 10 that is 150. Okay, so you add these two, it's going to be 250 meters. Okay, so that's our distance, which is 250 meters, just like that. Okay, then the speed, when the time is 40 seconds, so this one is a direct question. When our time is 40 seconds here, you're just going to trace from this diagram. When our time is 40 here, I want you to trace at 40 here, straight to a diagram here. It corresponds to this line, because this is where you're tracing where the object was moving. So it corresponds with what? With this time at 20 here. So your time there was 20 seconds. Okay, so the speed was what? Sorry, 20 meters per second. We are corresponding to the speed. So it's 20 meters per second, this one. Okay, so this is 20 meters per second. All right, that's it. Then the deceleration during the last 10 seconds. Okay, guys, remember that deceleration, you just take it from what? From acceleration. So it's negative acceleration. So you find acceleration, then you multiply by what? By a negative. So that's it. So that's your deceleration is equal to negative acceleration. And our acceleration, we know that this one is the change in velocity over the change in time. So this is just the change in velocity over the change in time. Okay, so that's it. So this is where our deceleration happened in the last 10 seconds from this 60 here. So it started from this one, which corresponds with what? With the 20 here. So it's going to be 0 minus what? 20, because you are now at rest. So it will be 0 minus 20, that's the change. So it's a negative 20 over the time, which is what? Which is 10. For the last 10 seconds, it's 10 there. So you're going to obtain negative 2 meters per square second. That is acceleration. But deceleration, you now multiply your answer by a negative, so it will be 2 meters per square second. Already, we are given the units. So here we just write the answer because the units are already there. All right, so that was it for the deceleration. You just find the acceleration, then you multiply by negative. Okay, number 23, you are given variation, partial. It is given that x varies partly partly constant and partly varies as y. So the first one, we have to just constant, guys. Remember your variation. Okay, then this one partly varies is constant and y there. That was it. Just we have combined this. Then B, given that x is 1, y is find the values of h and you find the value of k. So that one is just a matter of substitution, guys. X is 1, substitute here. X is 1. At that moment, y is equal to 8. So in place of y, you substitute 8. So it's going to be 8 plus h 8k. Okay, that's 8k. We move on when x is 3, our x is 3, which is equal to h plus our y in this case is 12, so it's going to be 12k. So subtract here so that we can eliminate the equations. That's it, guys. We just have to subtract and so on. Okay, so that's it. I'm just going to subtract these two equations. That's 1 minus 3, which is negative 2. H minus h, that's a 0 here. 8 minus 12, that's a negative 4. Okay, so this is negative 4k. Okay, so to find k, just divide by negative 4 both sides, by negative 4 both sides here. So this can cancel. So our k is going to be what? If you cancel this negative and negative, it's going to be positive. So k gives us a half. Okay, so using this k, we can find the value of h just using any one of these equations, just substitute wherever you can. All right, so I'm just going to take this one. I want to remove this one, guys. Okay, like this. Okay, so now I'm going to solve the value of k, which is a half here. I'm just going to use the first equation. So 1 is equal to h plus 8 multiplied by k, of which our k is a half in this case. So this is a half here. So 1 is equal to h plus a half of 8, which is 4. So we're going to have a 4 here. Then transpose the other side of the equation. So it's 1 minus 4, which is equal to h. So in this case, h is going to be negative 3. Okay, so that is what we got here, guys. So actually, just forgive me, guys, of this software that I'm using is actually something else. I mean, this it doesn't need me to write fast, but I don't know why. Okay, so that's it, guys. The value of h is there, the value of k is there. Then the other part, the value of x when y is equal to 30. Okay, so what is the value of x when y is equal to 30? This time you have to combine first from that formula that we have got here. We now substitute our values of h first. Okay, so you've got x is equal to h, our h here, we've got h here, and our h is -3. So we are going to have -3 plus k, our k is a half, so it's going to be half y there. So that is half y, because remember it was ky, so that is it. Now we can substitute the value of y, because we are told that y at this moment is 30. So in place of y here, substitute 30. So what is the value of x? We're going to have -3. Half of 30, that's 15. So we're going to add 15 minus 3 plus 15, that's 15 minus 3, which is 12. Okay, that's 15 minus 3, which is 12 there. Okay, so that was the idea from this part. So these are actually the typical questions that you're going to have, and it's very, very important for you to understand the concept. All right, let's move on to the other part on 24, that is information of ungrouped information that you are given. The table shows the test results and so forth. Find the number of pupils in the class. So how many number? We just add the frequency. This is the number of pupils who scored this mark. So you add these numbers here. So if you add properly, you're going to obtain 32. All right, so that's it. Then the model mark, remember the model mark is the one that has got highest frequency. Which one is got the highest frequency? Which one is 9 here? And it corresponds with what? With 4. So the 4 is the model mark. Okay, then the range of values of the marks scored. So range is maximum minus minimum. The maximum score which was scored in this case, which was the maximum score. So as you can see, the maximum score is 9. 10, no one scored 10 here. So the maximum score is 9. And the minimum is not 0 because we do not have any student who scored this mark. So the minimum is 1 because there's a person who scored this mark. So you subtract maximum minus minimum. So it's going to be 9 minus 1. That is what range means. So 9 minus 1, which is going to be 8. So that was our range. All right, then calculate the percentage of people who scored less than 5 marks. What is the percentage? So remember, percentage is number of students over the total times 100%. But they told us who scored less than 5 marks. So you have to go back to the diagram here on this table. So this is where we have got a mark of 5. They didn't say who scored 5 less than or equal to. They said less than, which means 5 and more than. This is not included. So our answer is going to be on this side. So how many students were there? From that part, you have to add. So you're going to add 1, 2, 3, 7, and 9, up to 4. These are the numbers that you're going to add, and you're going to obtain 20, if I'm not mistaken there. That's 10 here, plus 10, which is 20. All right, so that's 20 there. So remember, percentage, number of students who scored that mark over the total number of students. And we said we have got how many students? 32 students. So over the number of students, the total number of students, which is 32, whatever that we get, we multiply by 100%. Okay, so that was it. If you multiply by 100%, guys, make sure that you divide properly. You can obtain something like 62,5. So this multiplication, guys, I'm no longer doing them. I want you to work out them and do your division and so forth. Can you stretch yourselves further? Okay, that is it. I think that was clear. Number 25, that's a quadratic graph that you're given in this case. All right, that's a quadratic graph there. So the diagram shows the function of y is equal to x squared minus 2x minus 1. Use this graph to find the roots of the equation. So the roots of the equation is the original equation that we were given before. So this is where your graph crosses the x-axis. Okay, you're going to take the part where this graph crosses what? Crosses or passes through the x-axis. That is when it is equal to 0. It means y is equal to 0 in the x-axis. Okay, so where is your y is equal to 0? At this point here, and at this point where it passes through the what? The x-axis. That's where y is equal to 0. So this here is negative 0, 1, 2, 3, 4. Okay, negative 0, 4 according to scale. if I'm not mistaken, is that negative 0.14, guys? Where is our x? Okay, this is our 0 here. Yeah, this is negative 0.14, guys. Okay, yeah, that's negative 0.14 according to our graph there. So x is equal to negative 0.4, not 1, 0.4. So negative 0.4 here, because it's actually at this point here. Okay, so this is 0.4, and here it's 2.1, 2, 3, 4. Yeah, 2.4 there. All right, so that part is 2.4. So x is equal to minus 0.4 or 2.4. So these are the two answers that you're going to have, okay? Then the minimum value of the function. So this is the function that you're given. What is the minimum value of the function? The value of y here at this point. So what you do is that you draw where this graph turns here at the turning point like this. This is where your minimum value is. So you join this direct to the graph. As you can see, y at that moment is minus 2. So that is your minimum value. Okay, so y is equal to minus 2. Okay, then we move on to the equation of the line of symmetry. Remember, guys, I told you the equation of line of symmetry is the one that divides your graph into two equal parts. Okay, so it divides your graph into two equal parts. So you're going to see that here at this point at minus 1 here, this is where your graph is divided into two equal parts here at minus 1. Yeah, that is, guys, from the maximum value here at this point, your graph is divided into two equal parts. So this is your line of symmetry. X is equal to negative 1. So you write down the equation. This one is the equation. So it's x is equal to negative 1. Okay. Then D, the area enclosed by the graph. Take note, enclosed by the graph, x-axis. So we need this region first. Before we move on, this is what we need. The area that enclosed by the graph and the x-axis, it means this region here. So far, we are going to work with this region here. This is your x-axis, all right? Then this is your graph. So in between this graph here and the x-axis like this one, this is where we are talking about. This is the region that we are talking about there. So now they have added this part. The y-axis and the line y and the line x is equal to 2. So we are going to be limited now between the y-axis and this is your y-axis, this one. So you're going to be limited between this y-axis and the line x is equal to 2, and x is equal to 2 is this line which passes at this point here. This is your x is equal to 2, this one. Okay, so which means the region that you're going to be left is this one that I'm shading here. This is where your area is going to be located. Okay, so remember, guys, I told you area, you count these boxes together. Okay, so that's your area. You count all those boxes, number of boxes over 100 times the area of unity square. So the unity square now is the square of this graph here. This is the square from your x and y axis. As you can see, the first square here, this is your square. Okay, according to scale, this is 1 and this is 2. So if you multiply 1 times 2 is 2 square units. That is the area of what? Of the unit square. Okay, this one is 2. So number of boxes, count those boxes and see what you're going to get. So in this case, when I counted them, I got 268 boxes over 100, then I'm going to multiply to 2. Okay, so this is what I got, guys. And you have to play around these numbers and reduce them. You're going to obtain something like 5.36 square units. This is area measured in square units, not square centimeters one. This will be square units. Okay, so square units. So that was the idea in this particular section. Then number 26, it was to solve the equation. That was the first part here, to solve the equation. So this is just a normal equation, guys, as usual. Let's see where we are going to write it. We can even solve it here. Okay, so that was 2x. 2x minus 3 squared, which is equal to what? And this is equal to 9. Okay, so this is equal to 9. So as you know, guys, you have to get rid of what? Of the square root. How do I get rid of the square root? Introduce the square root both sides. So I'm going to have 2x minus 3 is equal to square root of 9, which is plus or minus 3. So in this case, I'm going to separate plus or a minus. So which means we are going to have something of this nature. 2x minus 3 is equal to 3, or this one, 2x minus 3 is equivalent to minus 3. So you separate the plus and the minus. This one, then you can transpose minus 3 to this side is going to be a plus. So 2x is now 3 plus 3, which is 6. Or 2x transpose to this one is going to be a plus also. So it's minus 3 plus 3, which is a 0 here. Divide by 2, divide by 2. So x is going to be 3, or x is going to be equal to what? X is going to be equal to 0. Okay, so that was it, guys, as you can see. Then from this part, we're given the equations here. These are inequalities, as you can see, guys. So we are given the equation of this line, which passes at A and B, which is 3y plus 5x is equal to 15. And you're asked to calculate the coordinates of A and B. So remember, guys, how do you find the coordinates of A and B? A is on the x-axis, where we know that y is equal to what? Y is equal to 0. So if y is equal to 0, I just substitute on this equation. Y is equal to 0, it means 5x is equal to what? 15. Divide by 5, divide by 5. So x is going to be what? 3. So this is your x is 3. So at A, the point is going to be 3 is 0 here, because we are given the value of x, which is 3, which is the same thing that you're going to do on your B here. Using this equation, you can actually, where is it going now? Okay, let's leave it like that. We go to our B here. This is your y-axis, okay, where we know that in the y-axis, x is equal to what? X is equal to 0. Okay, so I'm going to substitute now. X is equal to 0 in place of x, so it's going to be 3y would be equal to 5. Divide by 3, divide by 3, so y is going to be 5. So it means at B here, y is equal to 5. So the coordinates now of point B, we said x is 0 and y is what? Y is 5, just like that. Then item 2, we are asked to find the gradient of line M. Okay, this is our line M here, this one, this is your line M. So what is the gradient? You can take these 2 points, we've got -4 and 4, so you can take these points 0, 4, and -4, 0, these ones. So you use these points, find your gradient. Okay, I think I told you guys how to find the gradient. So you can use your gradient from there. Or in this case, I'm just going to use this one because I have got what? The graph. So I'm just going to use increase in y here over increase in x. So in this case, as I can see, I'm decreasing in y, so it's -4. I'm going to the negative to x, so it's also -4. So it's going to be -4 over -4. So gradient, which is m, is increase in y over increase in x. That's going to be +1. So that is our gradient, okay, which is here, gradient of line m. Okay, so we need the equation. So from the gradient, we are going to have the equation. So remember that your equation is in the form of y is equal to mx plus what? C. So if for the value of m, which is 1, so m is 1, so y is equal to x. That is 1x, just or x, okay? Then the c, which is the y-intercept. So the c, where is this line passing the y-axis? It is passing the y-axis at what? At 4. So that is your c here. It is passing through 4, like this. So that is our equation. Okay, then write down the 2 inequalities other than y is greater than or equal to 0, which define the region. Yeah, in our previous class, I managed to describe how do you take these inequalities. I think now we have that idea. So according to this line, I'm going to start with this line. Remember, I told you that this is the greater region and this is the lesser region. So you take this part that is not shaded, which is what? The lesser region. So which means our inequality is going to be 3y plus 5x like this is less than or equal to 15y. It's a continuous line, this one, okay? So that's it. Then we move on to this one that we just found its equation. Now we said our equation here is y is equal to what? Our equation is y is equal to x plus 4. Okay, this is our equation. And I also told you that for this line like this that you're having, your greater region is going to be this one on top. This is the greater region. This is the smaller region. So as you can see, we are working with the smaller region. So therefore, y is going to be less than or equal to x plus 4. Why less than or equal to? Because it's a continuous line. So these were the 2 inequalities that we are being asked in this question. Okay, so that was it, guys, for this question paper, which was actually written in November 2008, the full paper there. So we just need guys to work as much questions as you can, as you prepare yourselves for the exams which are to come. So that's it, guys, from Maths on African Motives, working on A-level maths till we meet again.